This is video homework for Tim Barron, Physics 350, Homework 5, Problem number 1. What they want us to do here is find the general solution to Laplace's equation in spherical coordinates, and we're going to assume that V only depends on R, and then they want an example of a charge distribution that this equation could apply to. So for the solution, we're going to start with the spherical form of Laplace's equation, and since this only depends on R, we don't need the second and third piece of this, which depend on theta and phi. So then we're going to go ahead and work with the equation here for R and set it equal to 0. So when we set the equation equal to 0, you can see that we get rid of 1 over R squared, and then we move down a little bit and we see that we get a constant, and then when we integrate both sides we get the equation that we see here with V equals negative C1 over R plus C2. As far as an example of a charge distribution that this could apply to, it could apply to the outside charge distribution of a sphere, but not inside a sphere with constant charge density. It would be outside the uniform charge distribution. In conclusion, to solve this problem, you needed to use the Laplacian equation in spherical coordinates and solve for just dependence on R, and the solution showed potential to be dependent on R alone and have two constants. The takeaway is that this would be suitable for a sphere in which we were looking at the electric field outside of the charge distribution, but would not be suitable dependent on R alone if inside the sphere.